Alright, you guys, so this is 8.1. We're going to be solving system of linear equations by graphing. That's our standard. And our goal is that you should be able to solve a system of linear equations by graphing the equations with an 80% accuracy given your practice problems for homework. So before we start, we have two vocabulary words to go over. The first one is system of equations, which is basically a set of equations that have the same variables. So in this case, we have these two equations and both of them have an x and a y. Okay, so that's basically what it means. And then the solution of a system of equations is basically the order pairs or order pair that's the answer to every equation in the set. So basically points that belong to both equations, okay, or whatever number of equations you have in the system is the point or the points that satisfy those equations. Okay, so we're gonna solve by graphing first. Okay, so we have these two equations, y equals negative x plus 4, and then we have y equals 3 plus x. We have to remember this right here, which we've been having as the beginning of the year. So this is our slope intercept form, and we call that because we have the slope and we have the intercept. Okay, so that's what we call the slope intercept form. Remember, this value in front of my x, my coefficient, is going to be my slope, which is my rise over my run. And this is my starting point, okay? My starting value, which is where my line crosses the the y-axis. So first thing I'm going to do is I'm going to graph the equations. Then I'm going to find the point of intersection where they intersect. And then I'm going to plug in values to both of those equations and see if the point that I got is correct, okay? So let me have the graph right here. Okay, so let me just write the equations right here. So I have y equals negative x plus 4, and then I have y equals 3x, okay? And remembering my slope intercept form. So this one is my starting point. So I'm going to start at 4, okay? So that is for positive 4. So I'm going to kind of see I'm going to cover that up, and I'm going to see that as my positive 4. So I'm going to graph 4 right here. This is my starting point. Now, this is my slope. Remember, there's a coefficient that we don't see. In this case, this is negative 1. So if it's negative 1, that means that my slope is going to go this way, right? So that means that I have to make that into a fraction, which is negative 1 over 1. So I'm going to go down 1 and over 1, okay? So I'm going to go 1 down, 1 over. 1 down, 1 over, 1 down, 1 over. Now, if I want to extend it this way, I'm going to go 1 up and 1 to the left to make it negative, right? So then I have this pattern that I already seen, and I'm going to connect the dots, okay? And I'll show you the other way that you can graph it as well with that. Doing that, which I think this is the easiest way. And then the second one is this. Now, when we don't see anything right here, that means that it's going to be a plus 0. So that's where my line starts at 0 at the origin, right here. Okay, that's a proportional relationship. And I'm going to create that as a fraction, which is 3 over 1. And this one is going to be going this way. So I'm going to go 3 up, 1, 2, 3, right? And then 1 over. So I'm going 1, 2, 3, 1 over. I already see something. 1, 2, 3, 1 over. 1, 2, 3, 1 over, and if I want to go this way, I have to go 3 down, 1, 2, 3, and then 1 to the left to make it positive. 1, 2, 3, 1 over. So then, see, I don't even have to graph because once I hit this, I see that that's where they cross. So this right here is my solution, okay? Because that point satisfies both of the equations. So my order pair is x comma y. Remember, x comes before the y. So I went 1 on the x and I went up 3. So that's 1 comma 3. And then I'm going to check to see if that's true. So I'm going to plug those values in. So then I have y equals negative x plus 4. I'm going to plug in values in. So I have 1 comma 3. So that 1 goes on the x, right? So I'm going to say negative 1 plus 4. Is that true that equals to 3? So 3 equals a negative 4 plus 4. A negative 1 plus 4. Remember, we have different signs in that addition, so I have to subtract absolute values. So 4 minus 1 is 3, and because I have more positives, then it's going to stay positive. So is it true that 3 equals 3? Yep. So that one got checked. Now the second one is y equals 3x. So I'm going to plug in values. The x right here, so 3 times 1, and then the 3 goes right there. Is it true that 3 equals to 3? Yep. So the answer got checked. So this is my solution. The solution for this system of linear equations is 1, 3. Okay? The other way to do it, which you can always do, is by graphing. Okay? So then, of course by graphing, but by setting up a table. So let me just show you one of the equations of how you can also do this. So you're going to pick a value of x. So I'm going to say -1, 0, and then 2. Okay? So then I'm going to plug in the value for that. So I'm going to say negative -1, right? And then, I'm sorry, and then +4. And I'm going to figure out what that is. So then I have, remember so we have a minus, a negative, which becomes a plus. So I have 1 plus 4, which is 5. So my order pair is -1, 5. Okay. Second point, I'm going to do the same thing. I'm going to plug in values. So -0 plus 4, which is just 4. So second point is 0, 4. And then the third point is y equals negative, and then plug in the x value. So 2 plus 4, different signs. So I subtract 4 minus 2 is 2, and I have more positive. So then I end up with 2, 2. Okay. So then I have these 3 points to graph, which is -1, 5, which is right there, and then 0, 4, which is right there, and then the last one 2, 2, which is right there, and then I connect. So it's the same thing. I just think this is more work, but you should also be able to do it from the table. Okay, so I'm gonna move on to the next one, so I don't make it that long. So you're gonna see also a different format of equations. So which is this right here, we call that standard form, and we need to get it to this so you can graph it a little easier. Okay, so we need to get it to this, to the slope intercept form. Okay, so you can graph it the way that I show you. So let me just go over how you can do that. Remember, we want to have the y on one side. So this is going to look a little complicated, but once we get to numbers, it might be a little easier. So I'm going to move anything that doesn't have a y to the other side of the equation. So I'm going to move this whole term right here. And when I do to one side, I have to do to the other side. So then I end up with by equals -ax plus c. Okay? And then what I'm going to do is I'm going to divide by b, and when I do to one side, I have to the other side, so I end up with y equals -ax over b plus c over b. Okay, that looks very complicated, but let's get it to this right here. So let me show you how to rewrite that into slope intercept form. So I'm going to move the x to the other side because I want to have the y on the left side. So then I do that. That cancels out, and I bring down my -y equals, I'm going to keep my x's first. I'm going to say -2x, just carry over the symbols, the signs in front of them. And then, so you might think that you're done here, but you're not, because the y is negative. So I need to change that. Now, basically what we're doing is we're dividing the whole thing by -1 because there's a 1 in front of it. So I'm going to divide by -1, divide the whole thing by -1. So then basically we're going to flip all the signs. So y equals -2 divided by -1 is just 2. So that's a 2x. So let me just rewrite this how you will see it. So it's -2x divided by -1. So I see it like that, and then I see that like that. -10 over -1. So then I have this is a positive 2x, and then -10 divided by -1 is just positive. So then I'm done there. Okay. So that's how you will write it. In slope intercept form. Now this one right here, I'm gonna do the same thing. I'm going to move the -3x to the other side, and then I end up with 9y equals, I'm gonna keep the x first, -6, and then I'm gonna divide the whole thing by 9, divide by 9. So this ends up to be y equals, and I'm gonna take them individually. So 3x over 9, and then I'm gonna take that like that. -6 over 9. Okay, so then I can simplify. Y equals 1 divided by, 3 over 9 is basically 1/3, and I'm going to keep the x there. And then this one I can simplify by 3's. So 6 over 9 divided by 3 over 3, which gives me 2 over 3. Or if you do decimal form, Never mind, don't do decimal form because you're going to end up with a repetitive number. So minus 2 over 3, and I'm done with that one. Okay. Now to check if the points belong to an equation, the only thing we have to do is plug in, okay, and see that both sides are equal. So this is my x value, this is my y value. So I'm going to plug in wherever, so I see my y right here. So that's, let me erase this. So my equation is this. So basically what I'm going to do is I'm kind of rewriting it, but I'm going to plug in values. I know that my y is 5, so I'm going to erase that, write the 5 right here. I know that my x is 0, so I'm going to erase that and write it 0. So I'm going to see if that is 5. So 3 times 0 is 0 plus 5, that's 5. So 5 equals 5. Yep, check. So this one works. Okay. And then I'm going to the next one. So I'm going to write y equals 3x plus 5. My x value is 3, so I'm going to erase that, write 3 right there. My y value is 10, so I'm going to erase that, write 10 right there. 3 times 3 is 9 plus 5, that's 14. Is 14 the same as 10? Nope, that doesn't work. So this one doesn't work. Okay, it doesn't belong to that equation. Last one. So y equals 3x plus 5. What's my y value? 20. What's my x value? 5. So 3 times 5 is 15 plus 5. Is it true that 20 equals to 20? Yep. So that one works. So that one belongs to that equation. Okay. So that is it for this one. I know it's a lot, but I promise you guys after this module, everything's going to be easier. This kind of like our cardio for our brain. To be honest, toughest module for 8th grade. So again, don't give up. You got this. Math is magical and you are amazing. Bye.